Okay, the last rule is power to power rule. So if I have power to power rule is I multiply powers together. So if I have power on this argument, I can bring it out front and multiply it to the log, or multiply the power. Remember, the log is your exponent or your power. Okay, so let's test this out. This is our power to power rule here. So if I have power to power, I multiply and I get 7. Okay, log base 10 of 7 is 7. Would I get the exact same thing if I do what this rule says? This rule says that this 5 can come to the front. Well, I put that as a times 5 in the front, so it's timesing the exponent of this. Well, if I work out the log, I get 1.4. Yeah, 5 times 1.4 gives me the correct exponent. Okay, and it works because we're power to power, we're multiplying exponents. So if I'm multiplying a log, the 5 is multiplying the exponent still. This one here, this is just a convenient way to split up roots. Roots are going to be fractional exponents or divide, and powers are going to be in the numerator, right? This is going to be an exponent times here. This is going to be a root here. Okay, so this is a power here, root here. So if I want to simplify this, I can write this as log 4th root 2 cubed. And I can write this as power 3 root 4 log 2. Okay, so that would be an equivalent expression. Here, if I want to solve this problem, well, how do I solve a problem like this? Well, I have to be careful. I need to get rid of the logs. Well, I can't just divide logs like that, because logs are not like a times factor or anything like that. So we can't do anything weird like that. We could only do that with like divide, but this is not times. So what I can do here is, since I have a plus here, I can combine those arguments with multiplication. So I don't have 2 different logs anymore. I just have one log on the left-hand side. And I have one log on the right-hand side. I've kind of made a similar argument to this before, but I'm going to make this argument. If the exponents are equal, I can say, and the bases are equal as well, I can say the arguments must be equal. So I'm just going to drop the log. So I didn't cancel anything out. I'm just going to make a logical argument that the exponents or logs are equal, bases are equal, the answers are equal. So there it is. Now I have an equation I can solve. X squared minus plus x minus 20 minus 22 is minus 42. And then solve this by factoring. So I get 2 answers. X equals -7, x equals +6. Now you would think I'd be done at this point, but I'm not quite, because with logs there are restrictions on logs. Okay, the arguments have to be bigger than 0. Okay, and the bases have to be bigger than 0, not equal to 1. Well, if I plug -7 in, I'm going to get a negative log. I can't log of a negative number. I can't take the log of a negative number. It doesn't work. The domain of a log is from 0, is bigger than 0. So this is an extraneous solution, and we always have to check for extraneous solutions when we're dealing with log equations.